FAIR is a team, and these partnerships start. Sound is okay to everyone?
Yeah.
So let's give a quick overview why we are here today. We are here today because Thursday night, 1 year ago, after the INTERGEO, we were dinner together, we were drinking a couple of beers, and we challenged each other to do something together. And basically today, we are presenting the result of a couple of beers, yeah?
A couple of beers, yeah. Then about 6 months of work, but the beer, it all started at beer and INTERGEO, so some of the best things start there, right? So, yeah,
okay.
Take it away.
Okay, I will start. So, morning everyone, and thank you for joining us. My name is Antonio Mendes. I'm working at Leica Geosystems, taking care of mobile mapping business across the world in the last 11 years. And I have the honor to have on my side Ted. Go ahead.
Yeah, Ted, so we're with TopoDOT. We're out of Orlando, Florida. We have presence here and all over Europe. And we basically focus on extracting digital models, digital twins from mobile LiDAR data. And of course, so we have a nice relationship with Leica, who does excellent mobile LiDAR systems and systems in general. And so we've known each other for a long time. Years back, as you know, all through the industry. We're kind of old, but we still do cool things. Again, so.
So, today let's talk about roads. Roads are arteries. Roads are the arteries of our cities. When they are healthy and smooth, everything flows. People, goods, and service. But when they are deteriorated, the entire system feels the impact. Safety risks, higher cost, and wasted time. So we are in Germany. We did a quick research, and there is this huge amount of kilometers of roads in Germany. How many roads exist in your own countries? So we are talking for 830,000 kilometers of roads in Germany. All of them need to be captured. All of them need to be maintained. Okay. Otherwise, we will have unnecessary costs and disruptions. So, let's try to understand how can we avoid all that. We can avoid all that if we are able to evaluate the pavement conditions. And there is a couple of key methods to measure these pavement conditions. We are talking about IRI, and IRI will tell us how smooth and rough the road feels when we are driving. We are talking about PCI, Pavement Condition Index, that gives overall score of pavement quality, often used by cities to plan maintenance. And we are talking about routing analysis that looks at the depressions in the wheel paths, which can affect safety and the drainage. Okay, so the solution that we would like to present is a solution that efficient and is safer, faster than use. And I will leave that picture for later for Ted also to explain and showcase something in the cool software of TopoDOT. But this was how IRI was measured in the past. So to measure PCI, we are talking also for a manual work, walking speed, people just basically taking notes, and then manually just take all that information in tables like this to evaluate and create their own reports. Again, we are talking for a manual work when we need to go for all this workflow. No. So, last year, INTERGEO, Thursday night, dinner, Ted, let's work and try to find something together we could deliver. And the solution that we are presenting today is the solution that combines our TRK mobile mapping solution and TopoDOT software. Okay, so we've got our processing software, we've got our SIG portfolio of mobile mapping system. I will not talk about nothing of this today, but I will tell that the systems that we recommend to work with mobile mapping are the Neo and Evo generation. High-end solutions that we can go for the millimeter level of detail in the point cloud. Okay, for that, we've got a comprehensive workflow able to capture, process, and adjust the data that will allow TopoDOT to do this amazing analysis that you will see after all. So our workflow for mobile mapping is the one you are seeing here. A perfect workflow that we can capture. Basically, one of the key features for us and cool features for us is the possibility to capture data in real-time kinematic. Means that today the complexity of the post-processing is not needed anymore. You can just basically, in the moment that you finish your acquisition, press the button to download the data, and 30 minutes when you arrive to the office, you've got already the point cloud or the image ready to go for the extraction software. Or if we need much more accurate data, we can go for this post-processing data. Anyway, let me just show in a quick way this video. And this is a long presentation. It will not fit in 20 minutes, so we are trying to speed up this a little bit. Okay, but here you can see, for example, our workflow with the TRK 500 Neo. So easy installation. A compact solution combines GNSS, IMU, image, laser scan, SLAM technology, etc. Easy to mount, one person setup, so it's not a beast as our previous generation of 55 kilos that we had to have muscles to set up all that unit. And the cool thing here is we are now open and work for the millennial generation. A really cool real-time visualization in the tablet in real-time kinematic aspect. So, what I would like to share here as well is basically how can we collect data. We've got a solution with a single laser scan, capture 2 million points per second, okay? And if somehow I realize that this data is not good enough, my suggestion is drive slower. If you are not able to drive slower, my suggestion is drive twice. However, driving twice, I cannot guarantee that the second pass I will have points in the middle. So we develop a rotation platform that driving twice allows to rotate the scanner, and now I've got a second profile with 30 degrees left, and then I can rotate also the profile, and I will have more data, 30 degrees right. So instead, in this case of 2 million points per second, I will have 6 million points per second. However, we still have our 700 solution with 2 laser scans. Basically, in this case, I can drive a single time with much more data with this cross-section kind of effect. Okay? The challenge here is driving twice, I could have the chance to have data like this one pass on the other, or like this one. How can I do a really accurate measurement if I have misalignments between point clouds? I don't. And by the way, this data is not from TRK, okay? This is not Leica Geosystems data. So what I will show here is our workflow. This data is a small pass for a TRK 500, one single pass. I drove north. Then I drove again, rotating the scanner, 30 degrees left and 30 degrees right. If I drove north, I also drove south. 6 passes all together here. This image means nothing. But this one is telling that in the middle of this process, I drove a 2.5 kilometers tunnel in Norway. I've got all these passes all together, and I validate the data in my own software called Cyclone 3DR, and you can find 91% of the data within 1 centimeter. However, I want to talk with someone that is used to work with point cloud. And I ask, my good friends from TopoDOT to do exactly the same analysis. And this blue baby means that we are now also within the same level of detail, the same level of accuracy for multi-passes. Saying that, I'm confident if the data, and I apologize for my voice, okay? I'm confident that if you need to drive more than once, we can deliver a homogeneous point cloud that now we can create all these perfect workflow to capture, process, get all that data for point cloud and image that goes straight to TopoDOT.
And it's one. Thank you, Antonio. So yeah, so it all starts with good data, because the things we'll show you now, nothing happens without good data, right? So let's tell you what we talked about that night a little bit at the beer, over a beer. Oops, I hit twice. Rutting. So we're going to start with pavement condition, actually. So what do we do with that good data, and what can we extract from it? We need an intelligent model to deliver and actually be paid for, correct? So that's what we're here. So the first tool, and we've had this for quite a while. We've used this for years in the U.S., and it's a pavement condition. And what it works is in the ASTM 6433 standard. But the bottom line is, what you will do is extract striping, come to our booth. That's easy to do, very automated. And when you select these, TopoDOT will go through and find all the pavement distress, classify it, identify it, classify it, assess its severity, and quite this quick, actually. It's not sped up too much at all for this. And we'll identify the points. Every one of these you'll see shoving bumps, basically, to the standard. There's quite a few characteristics. There are quite a few types of pavement. These are very nice streets in the U.S. We're very proud of them. But, you know, it's a lot of good. There's a lot of them like that, so it's really good. So anyway, that can be done automatically. And when you do that, you can actually take it. And if the next, okay. So you select that area, and that's all metadata now. So this goes very quickly. The next step, there's metadata attached to every one of those distress. And we basically then, the standard says divide it up into certain surface areas. So you tile it essentially, and then you give it a PCI index, pavement condition index, and you assess based on all the damage what that number is, and then your customer determines what maintenance they need, where they need to be done, and you know what needs to be done, where, to what process, and of course we give what everybody wants, a spreadsheet. So automatically we'll go through and we'll give you a table of contents, and then a summary of every tile area that was evaluated and what the damage was, and basically all automatic, all out the other side. Our typical markets for this in the U.S., our customers are doing smaller cities, you know, that just want to know, they want to fix the roads, they want to know where their damage is, what the intensity is, where they're going to have to apply maintenance, what the severity. We can tell them how much volume it'll take to fill it, to fill potholes, all kinds of, you know, basically all kinds of feedback. Very useful, very successful. This is what you do with all that good data that comes from that TRK system. Okay. We found when we started talking to Antonio, in Europe, there was a little more interest in the way you evaluate it. It's a little more rutting oriented. Everybody wanted to know rutting. So we said, okay, rutting is part of our index we were measuring, but you know, they wanted to look at it a different way. And one of the nice things about being TopoDOT, we respond pretty quickly and knocked off this in about 2 or 3 weeks for a new tool. And so this is a rutting analysis in the tool we've been doing. I think we were giving that to Hungary, I think. We were talking to Hungary. So this is a rutting analysis, and basically it's a kind of amazing. If you think it's easy to measure, there's about 5 different ways to measure a rut, and we had to figure out them all, and and we looked at them all. But basically, this comes out, it's very automated. Once you have the stripes, you just hit the button, and this rutting analysis will be done. The severity is color-coded. Obviously, the spreadsheet comes out automatically also, which everybody interprets, engineers like. You'll have the stationing, the spreadsheet. They'll put them all in over a Google Map overlays. They can see their entire city very quickly, see where the damage is. And if they want to drill down, the engineers want to drill down, we have ways of actually making that available in a Google Map or in this database, and they can actually see, like this is a line for each measurement, and green is good, yellow is bad, not so good, red is bad, So basically, you get that information very quickly, and so they have the analysis. So the next thing we did is we went on this IRI analysis. So Antonio, I think after 2 or 3 beers, he says, "You hear about IRI?" And I said, "Oh yeah, all right. I kind of know about it." And so we looked it up, and if anybody doesn't know what IRI is, that's it. It's a model where they make a single wheel model, and they run it along the road surface, and they see basically, if you really want to get into it, when the 2 masses move in different directions, you integrate the different directions, and you say that's the bumpiness of your ride. So if you're driving along like this, that's what the masses do. One represents the body, one represents the axle in the bottom. So it tells you how much, if you go in the same direction, it's okay. So it's kind of cool, and we like that. In another life, I was more involved when I did satellite control systems. I kind of did that kind of work. So I said, okay, this should be fun. So we set about to make a very cool model. And so we took that. And by the way, we're not the first to do this. This has been done for years. And you have on top the TopoDOT, you have the TopoDOT evaluation for a particular model or the particular data set, and against ProVal. ProVal is kind of the industry standard. So when you do something like this, you have to prove you're right. I did this model, it's moving up and down. How do you know the number's right? Well, we compared it to ProVal, and if you get the same number, you should be okay. So this is just a one section between TopoDOT response over a certain area, same data set, same input to the model, and we get 0.97, 0.972. They measure it in meters per kilometer. That's how much the integration is. If you look at it a little better, so that's one number, and that says, yes, it's correct. But if you look at ProVal results over TopoDOT results, over a continuous run, this is the IRI over a particular long length, and you move that, and it should do something. There you go. It's the same. So our model we know is correct. Okay, that's how you start, and you say, okay, so if I put the same data in both models, I get the same thing out. So now I take this excellent data, and I feed it into the model, and I'm very confident that everything's working. So we decided to do the world's coolest IRI analysis tool, because we weren't just, I've seen a lot of them, and a lot of them are kind of boring. They kind of go along, and they just make a number. ProVal will just say, oh, here's the data, here's a number. You can do that, and that's the most important thing. But we decided we should just make that a little more, have a little more fun with it. So basically, when you go through, you set what's happening now. That's a line. That's where the wheel is traveling. But we decided to give you a little graphic so you can see what's happening inside of TopoDOT. So basically, if you want to see it run, this is actually how the masses are going up and down, and there's its driving, and that's what happens in TopoDOT. We initially did that because it's really cool, and you can evaluate. This is the result you'll get inside from TopoDOT. Basically, it's the IRI analysis. There's different ways you can look at it. Move your window a certain area, do it a section at a time, whatever you like to do. And then you basically get a spreadsheet, all right? So on the stationings. And this all comes out automatically, very quickly. And we really like this. And now, does it serve a purpose? It's kind of interesting in the graphics. It actually does, because sometimes we've actually seen data where we saw a spike in the IRI, and you wonder, well, where did that come from? Did something happen? Well, you take the wheel and run it, and you see it go over a pothole or something that's substantial. Things go crazy, and the masses move a lot, and you go, all right, that's what it was. There's a pothole there. And when you're selling it to your clients, trust me, they like to see the wheel. They like to know what you're doing. So they like to understand it. It helps them understand what you're trying to give them instead of just seeing a number come up. Because you can wave your arms and say, I got IRI, but if you show them this, they go, oh, you got IRI. And so that's the kind of thing we did. And I think that's it. So we have...
That's it.